I want to take a quick look with DBOPTIMIZER at looking at database load. How do we find out what's going on a database? How do we know whether the database is idle or active or if there's a bottleneck? And what tools do you use? Do you use something like StatsPack? In this case, I'm going to use DBOPTIMIZER because I think it's the quickest and easiest, and I'll show you why. I'm going to double click on a database target. This is Oracle. Double click, and we're connected. We can browse the objects, but in this case I'm going to jump into looking at the load on the database. So I'm going to click on this graph icon. It's the profiler, and it'll quickly open up a graph showing us what the load is on the database. In this case, we see that the graph is empty. What this means is the database is idle. It means no one's putting any load on the database. Either there could be queries being executed, but either if they are, they're so fast we don't catch them, or there's no load being put on at all. So either the database is running super fast or there's no load. Basically, if there's basically this is telling us there's no issues, there's no hangups on the database. On the other hand, I'm going to start up a load. I'm going to use a tool called SwingBench. It's available free from Oracle. It simulates applications. In this case, I'm using SOE, Sales Order Entry. And we can see a load coming on right now. And it's actually going to be a pretty big load. How do I know it's a big load? Well, I can get my sense of orientation by looking at this max CPU line. That's the number of CPUs on the machine the database is running. And it means the maximum amount of CPU I can use. Ideally, I want to spend all my time on CPU because anything else represents a bottleneck or a concurrency issue or a block. Like I could be waiting for a lock, that would be a block. I could be waiting for I/O. I could be waiting for latch, which would be concurrency. So our good state is green on CPU, and I can see a lot of time spent on CPU. But what's the rest of my time being spent doing? And how much is it? I can jump down to the events section and get a breakdown. So CPUs only accounts for 23% of my time, and 67% is coming from log file sync. Now log file sync might sound a bit esoteric, and it is, but we can easily look it up in the DBO documentation, or we can look under the Oracle documentation, and we find out that it's commit. And we can see commit up here in the legend. When a user hits commit, they wait for the log writer to write out any transaction changes to disk to guarantee that if the database crashes, that information is kept and not lost. And what can we do about log file sync if we're spending too much time waiting for log file sync? There's two options. If I'm a developer, I can look at my code and see how often I'm committing and try to commit less. One example is if I have a loop that for every pass through the loop I do an insert commit, I could change that and say for every 50 or 100 records inserted, then do a commit, and that would reduce the amount of time spent waiting for log file sync. As a DBA, what I can do is try to move Oracle's log files onto a faster disk so that when a user waits for something to be written to the log file, it'll be faster. And I'll do that right now. So I'm going to go to SQL Plus. We can see I've already selected, but I can run it again. We can see the two active log files, redo 04 and redo 05. Then on the end drive, which I set up for this example, it's a USB memory stick, which is slow. And I'm going to move that to the internal disk, which will be faster. So I'm going to create 3 new log files. Alter database, add log file. And I'm putting on the C disk, size 50 meg. And I added 3 of them. Now I'm going to again look at which one is active. Right now, redo 04 is the active log file. This is my query for those interested. I'm selecting from VDAR log file to get the status, and VDAR log file to get the member or the file name, and VDAR log to get the status, which one's active. So I can see 04 is active. I'm going to issue the command alter system switch log file to make it change. Run my query again, and I can see my currently active is now on the C drive. So now I'm using one of the fast disk. Now the question is, how did that impact performance? Go back to DBOPTIMIZER, and immediately I can see the reaction to the changes I made in the database. Was that a good change? it's very clear that it was. Almost all of my log file sync time disappears. So I can select the first part where I'm on the slow log file. I can see 67% of my user's time is spent blocked or waiting for that log file sync, waiting for log writer to write to disk. Now I select the area after I put it on a faster internal disk. That log file sync time went down to 15%, 17%. So this is amazing. As both a DBA and a developer, I can see the impact of my changes on the system. If I was a developer, I could have changed my code and rerun it and seen what the impact was. So if I had that loop that was committing every pass to the loop, if I change it to every 50 or 100 passes, I could see what the impact is. Super quick, super easy, and the idea is anybody can use it. Whereas something like StatsPack, not only is it slow, it's not recommended to run it more than once every 15 minutes. We don't get that immediate feedback. It's also complicated. It outputs 30 pages of information, which basically takes a lot of time and expert knowledge to analyze. Here we've seen the load very clearly. Anybody can read it. Idea is when we're far above the max CPU line, there's some sort of bottleneck. What kind of bottleneck? We can identify it either by looking at the color of the bar and looking at the legend, or we can jump down to the event section, the top activity, and see what the top events are. In this case, it's log file sync. I look that up in either Oracle's documentation or DBOPTIMIZer's documentation, and we see there's two choices, either commit less or move the log file to faster disk. Makes it super simple and makes life easier. More demos to come, and thank you for watching.